Today we're going to talk about distance and time problems in systems of equations. Before we start, you need to remember the simple formula that distance equals rate times time, where r is the rate and t is the time. Now, for these questions, we are going to be talking about canoes and planes traveling with the current and with the wind speed and against the current and against the wind speed. In this video, we're going to talk about planes, but I want to reference both of them so you can see it. If you think about people that are canoeing in a river, you've got two different speeds going on. You've got the speed of the people that are actually in the canoe, and then you've got the speed of the water. When the people are traveling with the current, they're going faster because the water is moving them forward and their own speed's moving them forward. So they're going a little bit faster when they're going with the current. By the same token, a plane, when it's traveling with the wind speed, it's going a little bit faster. When the people in the canoe are going against the current is going to slow them down a little bit, and the same is true with the plane. When there's something called a headwind, the plane is going against the wind, and it's moving just a little bit slower. These two concepts are going to be very important in the course of this problem. If you take a look at our question, it says a plane takes about 6 hours to fly 2,400 miles from New York City to Seattle. At the same time, another plane travels from Seattle to New York City with the same average airspeed, but the flight only lasts 5 hours. We want to find the average airspeed of the planes as well as the average wind speed. Now, if you'll notice in this problem, I've given you a distance. It's 2,400 miles. To Seattle and then also to New York City. So the distance is the same. The times are also different. Now I didn't tell you which time the person is going with the wind and which time it's going against the wind. So you have to use common sense here. The plane that takes 6 hours is longer than the plane that takes 5 hours. So the 6-hour plane is traveling against the wind. They're traveling slower, so because it takes them longer, so they're against the wind. The plane that's traveling 5 hours is with the wind. When we write our equations, we're going to let A equal our airplane speed and W equal our wind speed. For the first equation, we are going to write out what it looks like when the plane is traveling against the wind. Now, to the side, I've written myself a note that the 6-hour one is against the wind so that I remember that. If you take a look at my equation right here, you set the distance of 2,400 equal to the time, which is 6 hours. The speed is going to be the airplane speed minus the wind speed because we're going against the wind, so our speed is going to be a little bit slower. So you take the airplane speed minus the wind speed. When you set up the other equation, the distance is still 2,400 miles. It only took us 5 hours because we were traveling with the wind, so that means that you can add the air speeds. So it's the airplane speed plus the wind speed. Now on first glance, these two equations look kind of confusing. So we're going to get rid of the 6 and the 5 that are in front of the parentheses, and when we do that, we're going to find that it's a simple elimination question. If you take a look over here, okay, if I have the 2,400 equals 6 times parentheses A minus W, I can divide both sides by 6. When I divide the left-hand side by 6, I'm going to get 400. When I divide the right-hand side by 6, I don't touch the A minus W in parentheses. It just gets rid of the 6. So that first equation is 400 equals A minus W, because the 6 is gone on the right-hand side of the equation. If we do the same thing on the other equation, we're going to divide everything by 5. 2,400 divided by 5 is 480, and then the 5 goes away. Now you can look at these equations and realize that it is a simple elimination question. So we're going to use elimination to solve this. If you come down here to rewrite your equations, you're going to add the two equations together. So 400 plus 480 is 880. A plus A is 2A. The W's cancel. Divide both sides by 2, and my airplane speed is 440 miles per hour. Now, if I want to find the wind speed, I'm going to take that and put it into one of my two equations up here. I've selected the second equation, so 480 equals the airplane speed of 440 plus W. Subtract 440 from both sides and you get that the wind speed is 40 miles per hour. Now you want to check to make sure you actually did it correctly, and the way that you do that is you go to your calculator. You know that you're going to want the difference in speeds times 6 to still give you 2,400 miles. So for the first one, I'm going to subtract the speeds. So 440 minus 40. If I multiply that by 6, I get 2,400, which is what I wanted. If I look at the second equation, I'm going with the wind, so I'm going to add the air speeds, multiply that by the 5 hours it took me to get there. I also get 2,400. Since this is true for both equations, my airplane speed is 440 miles per hour. My wind speed is 40 miles per hour. So when I write my answer, I would say the airplane is traveling at 440 miles per hour. And the wind speed is 40 miles per hour. Make sure to include your units because this is a distance and time problem.